the last lecture of the last lecture of today's of the this course the last lecture of this course is about edge computing. As we have learned, the sensing of the signals, the capturing of the data, how the sensors capture the data, and what are the activities that can be sensed, what are the sensing techniques. Now the final thing is about the computation, and that for that case we are talking about the edge computation, that is the on device learning rather than the remote computation. The early methods in the early methods, the IoT devices could only connect and send the data to the cloud or remote server for the analysis. However, with the increasing computing capacity of today's devices, which this allows them to perform complex computations on the device, that is the mobile computing, resulting in the edge computing. The mobile computing is also known as the edge computing. As a result, edge computing extends cloud computing capabilities by bringing services close to the edge of a network, and thus supports a new variety of AI services and machine learning applications. Edge computing is transforming and revolutionizing how data is being managed, processed, and delivered from billions of devices worldwide. The huge increase in the number of IoT data sources, such as the camera, sensors, embedded system, personalized devices, such as mobile phones, this gives rise to the network edge computing. The network edge computing tries to move data processing, local storage, and filtering close to the data sources, and thereby moving the further computation towards the edge. In case of the edge computing, high-speed networking technologies, including 5G networking, enable edge computing devices to accelerate the development and deployment of real-time application on the edge or the device. Such applications include robotics, video processing, smart video analytics, artificial intelligence, autonomous driving, medical imaging, machine vision, industrial inspection, etc. Because as you can also see in your day-to-day life, all these mechanisms can now be performed on the smartphone or the mobile itself, that is the edge, for the computation. In its beginning, edge computing was assigned to mitigate bandwidth cost for data traveling long distances due to exponential growth of data generated by IoTs. But nowadays, as we have kept the edge closer to the data sources, that has not led to that is reduced the bandwidth cost also. One edge is the edge which is a computation device far away from the data sources, and one of the aspect of the edge computing is the mobile computing, in which all the computation is being done on the same device in which the data is being captured. So now we can see that how the technology is now progressing because of the rise in real-time applications that need processing at the edge rather than the remote services. As it can be seen in the figure also, the usable data created per year and the data-centric traffic per year. The usable data which is created per year is increasing at a very greater pace, and the data-centric traffic per year is also increasing in a bit amount. So as the data center has leading to the low capacity, thereby enabling the usable data which is created per year for the opportunity of edge or fog computing. Among the wide range of advantages, the data reduction at the network edge connected edge devices can prevent bottlenecks and dramatically lower storage, energy, and bandwidth costs. There are certain advantages of edge computing. Firstly, it brings the data storage and computation closer to the hardware where its collection is taking place, rather than depending on a central location located several miles away. Edge devices extend the cloud to a network of connected local edge nodes where the data is collected itself. The edge computation do not suffer latency issues as the data do not need to be transferred from one place to another and for longer distance. The edge computing is also very cost effective by getting the data processing done locally on the mobile devices itself. This computing also reduces the bandwidth cost and the bottlenecks of cost spikes. Next, the edge computing was introduced because of the enormous growth of IoT devices, which connects to the internet to transmit information to the cloud or receive data from the cloud. So a lot of IoT devices generate huge volume of data during their operation, especially when processing the data of the cameras or visual sensors or video data. So such huge amount and large memory storage data needs to be processed at a local device, or even if it is not able to be processed at the local device, it can be computed at the edge. The decentralized character in the edge computing makes the system more robust since the individual edge nodes can operate autonomously and provide offline capabilities. Hence, mission critical AI applications depend on highly reliable infrastructure that only edge computing can provide. The edge computing also has the business advantages and it is beneficial in case of business perspective. Firstly, new business opportunities throughout the through the real world applications are coming into existence, which requires edge computing usage. In the business, they equip machinery and equipment for condition monitoring also require edge computing. The edge computing improves uptime, lower maintenance cost, and automate operation workflows in the business also. It also prevents business interruptions and breakdowns because the data need not to be sent at a larger distance, thereby it preventing the loss of failure or privacy breach of the data from the business point of view. So these are the overall advantages of the edge computing. This was the complete topic about the mobile computing. Like what exactly is the mobile computing? What are the steps or processes taken place in the mobile computing? And what are the technologies used in it? And further, how the computation is made possible in an easier mode. So thank you for attending the lectures.